Welcome to part 2 of our port-based NAC via 802.1x and OpenFlow integration scenario. In this video, we'll discuss the items at the bottom of the slide in bold. We'll start with the network access control implementation details for the wireless scenario, including relevant logical diagrams to understand the integration details, the wireless LAN authentication steps to illustrate a packet walkthrough of how a user is admitted into the 802.1x and OpenFlow networks, a sample VTN configuration so you can replicate the programmable flow configuration for this scenario, and then a physical diagram to illustrate the topology for an upcoming demo. We'll conclude the video with a demo of the wireless 802.1x and OpenFlow integration use case. Recall in part 1 of this video, we discussed some high-level design concepts as shown at the top of the slide, including the authentication methods available via Radius and use case scenarios for DHCP server homing. We also covered the network access control implementation details for the wired scenario. To start this video though, let's get into the NAC implementation details for wireless. In this slide, we're showing the mapping of virtual networks to the physical topology. Starting with the physical topology below, users connect to a wireless access point, which acts as a thin client forwarding all traffic to the wireless LAN controller, or WLC. The WLC in this scenario is both the DHCP server and 802.1x authenticator. The Radius server homes to the traditional network switch, which has an uplink configured as a trunk port to the programmable flow/OpenFlow network. The OpenFlow network is configured and cabled as a spine leaf representing a campus fabric. To the bottom right of the physical topology diagram, we see a number of secure resources or servers connected to the OpenFlow network, including an NFS and a web server. Jumping to the virtual network view, we have a number of VTNs which may isolate wireless users from the rest of the network. Users use the VLAN mapping technique to be mapped into the proper virtual tenant network, or VTN. We'll show further details of this scenario in the next slide. To illustrate how the VLAN mapping technique may be used to isolate different users into different virtual networks, we're showing customer 1 being mapped to the green VTN and customer 2 being mapped to the pink VTN. When customer 1 is authenticated via Radius, the Radius server allocates a VLAN ID of 14, allowing the wireless LAN controller to forward all of customer 1's traffic into VLAN ID 14 through the traditional networking switch and to the OpenFlow network. When the programmable flow/OpenFlow network receives traffic from VLAN ID 14, it's mapped into the green VTN, allowing customer 1 access to the web server. Similarly, when customer 2 is authenticated, the Radius server allocates a different VLAN ID. This allows the programmable flow network to map customer 2's traffic into the pink VTN, allowing access to the NFS server. This illustrates we can isolate users into different virtual tenant networks and also isolate them from the wired users. Also recall in this scenario we're not showing the DHCP server in the virtual network since the wireless LAN controller offers IP addresses to customer 1 and customer 2. In the next slide, we'll show a detailed packet walkthrough to understand the authentication steps. In this slide, we'll detail the packet walkthrough to show how a wireless user may be admitted into the 802.1x and OpenFlow network. First, in step 1, the user connects to a wireless access point running WPA2 Enterprise. This allows a wireless user to send their credentials via an EAP or PEAP frame. In step 2, the wireless access point forwards all traffic to the wireless LAN controller. Recall the wireless LAN controller is the 802.1x authenticator in the wireless scenario. When 802.1x traffic hits the WLC, it generates Radius packets containing the user credentials and MAC address, which are forwarded to the Radius server. In step 3, the Radius server sends an access accept message, assuming the user credentials are accepted, with the appropriate VLAN ID for the user connected to the wireless network. In steps 4 and 5, the user requests and receives an IP address from the wireless LAN controller, which is acting as the DHCP server. In step 6, the user may now send traffic, which is forwarded through the wireless network, the traditional network switch, and up to the OpenFlow/programmable flow network. Using the VLAN mapping technique, the user is admitted into the appropriate virtual tenant network. Next, we'll show you the programmable flow controller configuration used in this scenario as well as in the upcoming demo. Here we're showing the VTN configuration for a wireless scenario. Notice we have a VTN called wireless VTN that's configured with a vBridge called VB14. This vBridge has a VLAN map that ensures any tag traffic received with a VLAN ID of 14 from our wireless users is mapped into the wireless VTN. We also have a vExternal called VE44. A host connected to the proper port and sending traffic with the proper VLAN ID is mapped to this vExternal. This ensures that wireless users have access to an appropriate secure server. Next, we'll show you a physical topology diagram for the upcoming wireless demo. This diagram illustrates the full topology for the upcoming wireless demo. In this scenario, a wireless user running Windows will connect to a Maru wireless access point. To the right of the wireless client, we're showing a Maru wireless LAN controller acting as the DHCP server and the 802.1x authenticator. The Dell PoE switch simply forwards traffic up to the OpenFlow network provided by Programmable Flow. This network is configured and cabled as a spine leaf representing a campus fabric. Once the user authenticates, they'll attempt to access server 4, shown in the bottom far right, with an IP address of 44.1.1.44. Let's go ahead and jump into the demo now. This last portion of our demo shall show a wireless Windows client attempting to access our 802.1x and OpenFlow networks. In this scenario, the wireless network is called Jenny WPA, and it's running WPA2 Enterprise to exchange credentials all the way up to the Radius server. First, let's dive into the 802.1x client configuration. Similar to the other scenarios, this scenario will use PEAP to exchange user credentials. With the credentials properly configured, we may now attempt to join the Jenny WPA Enterprise Network. As shown in the window here, we've been properly authenticated via 802.1x. Next, we'll verify that we received a DHCP address from the wireless LAN controller acting as a DHCP server. As shown here in the command prompt, we've received an IP address of 14.1.1.2 from the wireless LAN controller. Next, we can verify we have access to proper network resources by running a ping test to a secure server. In this wireless scenario, we have a wireless VTN, which allows us access to a secure server with an IP address of 44.1.1.44. Next, we'll switch views to the PFC GUI so we can see how flows are mapped to the physical and virtual networks. We switched views, and now we're highlighting the Programmable Flow Controller's desktop GUI. Recall from earlier demos that the same view is supported from the web GUI. On the left, we're illustrating the virtual topology. In this scenario, we've highlighted a single VTN called Wireless VTN. Earlier in the video, we illustrated PowerPoint slides that showed the PFC configuration for this scenario. Right now, we're highlighting a single flow that shows how traffic moves over the virtual network from the wireless client to the secure server labeled VE44. Continuing the demo, we'll show the flow for the reverse path from server to client. Moving over to the right, we're showing the physical topology as well. In this scenario, we have an icon labeled server in all caps, which represents the secure server labeled VE44 in the virtual view. This shows that we can see both the physical and virtual networks, as well as the associated OpenFlow rules, and how traffic moves across the physical and virtual networks from a single application. This concludes our demo, where we illustrated how 802.1x may be used to integrate with OpenFlow and Programmable Flow technologies to implement network access control for both wired and wireless users. To recap the second video of our 802.1x and OpenFlow integration series, we covered the bottom items highlighted in bold. We started with the network access control implementation details for the wireless scenario, including the logical diagrams to highlight the integration details, the wireless LAN authentication steps, a sample VTN configuration showing the PFC configuration for the scenario, and then a physical diagram for the topology used in our demo. We put it all together by illustrating a demo of how a wireless user may be authenticated and admitted into the 802.1x and OpenFlow network.